In this section, we're going to learn how to rewrite equations and formulas. First, we're going to work to isolate a variable in a literal equation, and then we'll rewrite an equation so it's in function form. So a literal equation is an equation in which the variables or the numbers have been replaced with variables. So this example would be an example of a literal equation. We don't have any numbers, and it's asking you to solve this equation for x. So really all that's asking you to do is it's asking you to isolate x. And we're going to do this in the same way we've solved an equation. We're going to undo using inverse operations by doing reverse PEMDAS. So in this example, x is being bothered by a, which is multiplying, and also being bothered by b, which is adding. So because we're doing reverse PEMDAS, we're going to undo the addition first by subtracting b from both sides. So I end up with ax equals c minus b. And then I still have to get rid of a by dividing both sides. So x equals c minus b over a. So for this example right here, I'm being asked to solve for h. So h is being bothered by b and 1/2. So I really don't like that fraction first, so I'm actually going to get rid of the fraction. And to do that, I'm going to multiply by the reciprocal. So I end up with 2a equals bh. And then I still need to isolate h by dividing both sides by b. So 2a over b equals h. So now I've isolated h. Now that I've isolated h, I can use the information here, which says the triangle has an area of 64.4 and a base of 14 to find the height by just plugging into 2 times the area over the base and doing out that math. And that would give me a height of 9.2. Now, you could have also worked with this original equation, a equals 1/2 bh, and plugged in a and b there, but you'd be doing the same process to get h alone. So the reason this can be useful is if I had to find multiple heights for different areas and bases over and over and over and over, this, I've already solved my equation, so I can just calculate every time twice the area divided by the base. So give these two examples a try. Here you're going to solve for x. Here you're going to solve for L and then find the length given this information. Make sure you solve for L first on this example. Pause the video, press play when you're ready to check your answer. So on this first example, I would subtract p from both sides and then divide by q, so x equals r minus p over q. So then if I knew r, p, and q, I could find x for those values. And if r, p, and q were constantly changing and they wanted to say, okay, what if it was this, and this, what's x? Or what if you change it to this, and x? You can find x without having to isolate every time. Here we're isolating L, which is being bothered by W. W is multiplying, so we're going to divide both sides by W. So length equals area over width. And then I plug in the area and the width to find the length, which would be 27. So again, if I wanted to find different lengths for various areas and width, this would be the formula, the rewritten formula I would use, because then I don't have to isolate every time.